Ground-penetrating radar or GPR is a non-destructive geophysical method used to image and detect subsurface structures and features. Recently, in a news about an archaeological survey, the ground-penetrating radar was being considered for investigation, so it is a good idea to discuss on the same. So before we start, a quick disclaimer: this is purely a technical video, and it had no connection with that archaeological survey. GPR works by sending pulses of electromagnetic waves into the ground and recording the reflections that bounce back from various subsurface materials with different dielectric properties. The system consists of a transmitter antenna that emits the radar signal and a receiver antenna that captures the reflected signals. By analyzing the time delay and amplitude of the reflected signals, GPR can provide valuable information about the subsurface without the need for excavation. Here's how ground-penetrating radar works. Step 1. Radar signal emission. The GPR system emits short pulses of electromagnetic waves, typically in the microwave frequency range, into the ground using the transmitter antenna. Second step. Propagation through the ground. The emitted radar waves travel through the ground, and as they encounter different materials with varying dielectric properties like soil, rocks, voids, buried structures, some of the waves are reflected back towards the surface. Third step. Signal reception. Here the receiver antenna records the reflected signals. Fourth step. Data analysis and interpretation. The recorded data is processed and analyzed to create a subsurface profile, often displayed as a cross-sectional image, radiogram. Changes in the dielectric properties of the subsurface materials cause variations in the reflected signals, which are used to identify buried objects or structures. Now we know how ground-penetrating radar works, let's look at its applications. Out of the numerous applications, few main applications of GPR are archaeology, where GPR system is used for locating buried structures, artifacts, and ancient remains without excavation, helping archaeologists understand the subsurface features of historical sites. Utility companies use GPR for detection, like mapping underground utilities. For example, underground pipes and cables, in order to preventing damage during construction and excavation projects. Environmentalists used GPR to investigate soil and groundwater contamination, locating buried drums, tanks, or hazardous materials. In geology and subsurface studies, GPR is used to study geological formations, identifying bedrock, faults, and other subsurface features. In civil engineering, GPR is used for assessing road and pavement conditions, detecting voids, and evaluating the integrity of structures like bridges and buildings. Well, how can we leave the forensics? In forensic analysis, GPR is used to locate buried evidence or clandestine graves in criminal investigations. Now, after knowing the technology and application of ground-penetrating radar, let's see how specifically it is applied to archaeological surveys. First of all, it is a non-destructive method. Thus, GPR allows archaeologists to explore and map subsurface features without disturbing the site, preserving its integrity. It is also a time-efficient method. It helps target specific areas for excavation, saving time and resources in the field. The high-resolution imaging of GPR provides detailed images of buried structures and artifacts, aiding in the interpretation and planning of excavation activities. This technology offers a clear visualization of subsurface layers, enabling archaeologists to identify potential cultural deposits and anomalies. Finally, by identifying buried hazards, GPR helps ensure the safety of excavation teams. In summary, ground-penetrating radar is a valuable tool for non-destructive subsurface investigations, and its application in archaeological surveys has revolutionized the way archaeologists explore and understand historical sites. So, hope you enjoyed this video. Please click on the like button. Give your valuable comments on this video. and subscribe to this channel. Thank you.